Okay, so our next example has 3 pieces. And because it has 3 pieces, I am going to have 3 colors, just to be clear. I'm going to do the first piece in blue, I'm going to do the second piece in red, and we'll do the third piece in green. So I'm going to look at the domains first. So on the domains that have less than 1, equal to 1, and greater than 1. Because I have 3 ones here, I'm going to have 3 sections, and I'm going to have 3 ones. I'm going to have a blue one in the first section, I'm going to have a red one in the second section, and I'm going to have a green one in the third section. Okay. Now I also have to have, in the blue section, I have to have things that are less than 1. So things that are less than 1 are like 0 and -1 and -2. Okay. And in the green function, I have to have things greater than 1. So 1, 2, 3. It keeps going. Okay. So what I did here is I saw that there's 3 ones, so I went ahead and put 3 ones down, and then I continued up. X is less than, so a little bit less than it, and some that are greater than it, so a little bit greater than it. But I went straight for the endpoints because I know there has to have 3 endpoints. Now, if I assume that all 3 of these were in the domain of the actual whole function, then this wouldn't be a function, would it? Because the x number 1 in the domain is trying to date like 3 different values, and that's not cool. So only one of these can be closed. Which one is closed? The blue one, the red one, or the green one? Well, it's the red one. The red one is closed, which means the other 2 ones have to be open. The blue one has to be open, and the green one has to be open. And the reason this open for the blue and the green but not for the red is because of the symbols. Strictly less than is not closed, it's not defined there, so therefore it has to be open. Strictly greater than in the green is not closed, so therefore it has to be open. The only one that is closed is the red because it's equal to. Okay? Now all of the other blue points are closed, all of the other green points are closed, all points are by definition are closed, except these are the ones that are tricky, so that's why we're writing those down. You wouldn't need to write closed on every single point, that's kind of silly, but some students just kind of assume all of the points in blue are open. No, all of the points in blue are closed except for the 1, and then all of the points in green are closed except for the 1. Okay? Alright, so when I plug these in, I have -2 plus 3, that's 1. -1 plus 3, that's 2. 0 plus 3 is 3, and then 1 plus 3 is 4, but that's an open circle. Let's go ahead and plot that. -2 comma positive 1, -1 comma positive 2, 0 comma 3, and 1 comma 4, I have an open circle. Now, because I have a dot dot dot, that means I'm going to keep going. I could keep going, I just don't have the time to write all of the values, so I'm going to just draw it in my picture with an open circle. Okay, for the red function, if I have an x is 1, then my f of x, or my y, is just 5. That often happens when there's only one value in the domain. Instead of having something with an x where you have to plug it in, usually the function just gives you what it is because there's no variable there, so that just basically works it out for you. So in this case, it's going to be 5, which is right here. And that's just 1 point. Because there's only one value in the domain, there's only 1 point on the graph. In the green, I have the square root of 1, the square root of 2, the square root of 3, the square root of 4. The square root of 1 is 1. The square root of 2 is, I don't know, I'd have to get a calculator. It's like a 1.4 or something. But, yeah, it's not that helpful to me. I don't really want to work that one out. And so what I'm going to do is, because I'm the one that picked these values, I'm just going to take them out. Okay? I don't want to use root 2. Do you know what root 3 is? I don't. Okay? Do we know what root 4 is? Sure. Root 4 is 2. What is the next square root that I do know here? 9. Square root of 9 is 3. Could you use the other values? Yeah, probably if you had a calculator, but I don't have a calculator, so I'm just going to pick the ones that I know. So at 1 comma 1, I have an open circle. At 4, comma 2, I have a closed. At 9, comma 3, I have a closed. All the values are closed except for the one that I marked as open. So this is like that square root function, which is kind of like a parabola on its side with one arm cut off. And is this a function, yes or no? Passes the vertical line test? Yeah, you're not drawing these, you're passing your pencil through. And even at 1, there's only one defined value. It's the red value. The two open circles aren't defined there. And yes, it passes the vertical line test. So, therefore it is a function, and I didn't overgraph. Okay? A common student mistake is like when they're drawing the blue function, a lot of students will just keep going, and that's not true. The function is only defined for less than 1, so you only get from 1 and to the left. Okay, for the green you're only defined 1 and to the right, so you have to make sure that you're only sketching the part of the graph that you're allowed to sketch for that piecewise function. Our next example here is f of x is equal to the absolute value of x if x is not equal to 2, or 0 if it is equal to 2. Okay, this one's tricky, the not equal to. What I want you to think about this not equal to, and we'll do that one in red, and the other part in blue. The not equal to, I need you to think that as like x is less than 2 and on x is greater than 2. Anything less than 2 isn't equal to 2. Anything also greater than 2 is not equal to 2. So I want you to kind of think about this as two parts, to the left of 2 and to the right of 2, but not equal to 2, okay? The blue is the only part that is equal to 2. So when I draw my t-chart, I'm going to actually have 3 2's, okay? I'm going to have the blue 2 in the middle because that's the one value that is equal to 2, and that's closed. And then I'm going to break this red part up into 2 sections. 2 and less than 2, and 2 and greater than 2. Now these keep going forever, and so therefore they'll have arrows. The 2 red 2's are open, and the red sections are all going to go into the first function. But I like to do it this way because it goes from -2 all the way up to +5 and so it's like kind of in order, and I'm just thinking there's a piece kind of to the left of 2, because that's anything less than 2. And there's a piece to the right of 2, that's anything greater than 2, and you put those two things together and that means not equal to 2. Alright, let's go ahead and plug this in. Absolute value means make the inside positive, or distance from 0. So the absolute value of -2 is 2, the absolute value of -1 is 1, the absolute value of 0 is 0, the absolute value of 1 is 1, and the absolute value of 2 is 2. Let's keep going. Let's keep going down to the red. The absolute value of 2 is 2, the absolute value of 3 is 3, the absolute value of 4 is 4, and the absolute value of 5 is 5. In the blue, we have if x is equal to 2, then the answer is 0. Alright, so let's go ahead and graph this. We have -2, +2, -2, 1, 0, 0, 1, 1, and at 2, 2, I have an open circle. So I can kind of see what's going on here. That's that V graph. At 2, I have 2, 0, and that's in blue. And then back to the red, I have 2, 2, open circle again, so that's still open circle. 3, 3, that's closed. 4, 4, 5, 5. All of the values are closed except for the one value that I've marked as open. Okay, all of the other red are closed because all values by default are closed. It's almost, you don't even need to write it, but some students think just because I put open on 2, 2 that all of the red values are open. They're not, okay? Alright, and that concludes graphing piecewise functions.